derivatives of inverse trigonometric functions. So recall that the derivative of one example of a transcendental function is, for ln x, is what? Okay, remember that the derivative of that is 1 over x. And that transcendental function became, the derivative of that became an algebraic function. Now for the derivative of inverse trigonometric functions, we are also going to see the same trend. The derivative of inverse trig functions are going to be algebraic. Okay, so if we let the function to be tangent x, the inverse function is arc tangent x. And sometimes other notations could be tangent inverse of x. Okay. So for us to find the derivative of that inverse tangent x, we use the formula that we've been using before for derivatives of inverses, which is the reciprocal. So that's 1 over f prime, so that's the derivative of the original function of the inverse. So what happens is, we know that from the original function tangent x, the derivative of that is secant squared x. And so we also know that secant squared x in terms of tangent from the trigonometric identities, particularly the Pythagorean identity, this is also equivalent to tangent squared x plus 1. Okay, so if this is the derivative, what we do to find f prime of the inverse, or g of x, what the result will be is we are going to plug in, or we're going to substitute the inverse into this function right here. So it will be as follows. We have 1 over tangent squared of inverse tangent x plus 1. Simplifying that over further, this tangent squared of inverse of tangent x, that just becomes x to the power of 2. And so we have this formula, 1 over x squared plus 1. So that is now our formula that we are going to use to find the derivative of inverse tangent x right here. So the rest of the formulas are as follows. Note that we just found out the derivative of inverse tangent x, which is x squared plus 1 over x squared plus 1. But as you can see in these formulas, they already implemented the chain rule within it. So that's why there is a u prime being multiplied on the top, and at the bottom you have 1 plus u squared right here. Okay, so let's try to work on some examples. Okay, the first example you are asked, or the first problem you are asked to find the derivative of inverse sine of 2x. Or in other words, arc sine of 2x. So following this formula right here, I know that I have the inner part is 2x, and so the derivative of 2x is 2. So to find the derivative of that, I will now have the derivative would be u prime over square root of 1 minus u squared. That becomes 2 over square root of 1 minus 2x squared. Simplifying that further, I'll have 2 over square root of 1 minus 4x squared. Okay. Try to do the next problem, the B problem. Which is find the derivative of arctangent of 3x.